Managing silt and ground movement. I'm glad we're speaking about infiltration systems because silt and ground movement aren't WSUD problems. They're natural. They occur out here every day. They existed millennia before WSUD and they'll exist millennia after WSUD. Don't see them as problems to put you off using WSUD. WSUD can help us manage these really well. So, not much bio, not much pretty, lots of concrete coming up. What I'm speaking about, just a couple of very simple ways to stop WSUD devices silting. A little bit of info on reactive soil with infiltration. You don't get to ask question 3. If I'm speaking, you're getting trees with that, whether you like it or not. Sorry about that. And no apologies for that. Trees are the best tool. And what next? Silting. This car park's meant to drain into a swale on the reserve, and it did for a little while, and then the chute silted up. So now we didn't design it to have those classic reflections. You don't want a swale in a car park. It's not really a good outcome. You can see what's happened. Just silt. The entire catchment is that small car park. There's no inflow from the road. Tyres grind on asphalt. Things blow in. Sediment. Problem. Just in conversation with John Argue one day, Professor John Argue, he said, people are not putting in rain gardens, losing so many good opportunities because the perception of silting being a problem. He said, all they need to do is put a side entry pit immediately upstream from the inflow, and that becomes a sedimentation basin. How simple is that? Anyway, if you want to address that sort of silting, you've got to come in, get some machinery, disrupt everything, noise, diesel, kids can't play in the park that day, compact the soils, and you take it back to the level you need and rebuild it. You don't want to be doing that every few years. It's expensive, time consuming, hazardous. Thinking on John Argue's build a side entry pit idea. Ideally we'd put a pit here in the car park. Concrete takes up too much space anyway. I really hate giving another square metre of reserve to concrete. We need more space, more nature, not less. Concrete takes up too much space. But that pit's 1.5 metres deep, open to the soil, no concrete base, all the sediment straight into it, nothing in this is a swale, rain garden, soakage trench combination. And those pits, we took some soakage deep so we can run it across the reserve. It works. A few years later, forgive the landscaping. Landscaping never gets enough budget with engineering. All you engineers, add 15-20% to your budgets to cover landscaping. Do it. But it works effectively, no problem. So if we wanted to upscale that, and something that's not quite so ugly as a grated pit, side entry pits. Expected, you see them everywhere, no one really notices them, just drive past. I suggested using side entry pits a long time ago as a feed-in to soakage systems, infiltration systems. Oh, they block up with sediment. So what do? If they block up with sediment, you come up with a way to keep the sediment out. Sediment builds up at the bottom. So take the outlet, that's a 1.5 metre deep pit, make the outlet up off the bottom. That's about 700 deep. And a couple of outlets there into a soakage trench that runs along that verge. We're putting stormwater off the road, 100 metre catchment, straight up behind the curb. Inside the pit, where those two pipes came out, to keep the sediment out of the system, just a coil of ag pipe. And the open ends went into the soakage system. So the ag pipe is just a filter. And half bury that in gravel. No sediment can get into the soakage system. It's really cheap, really effective, works well. Another non-standard is there's no concrete base to that side entry pit on the side of the road. It's just natural site soil, silty clay. Because your water drops head pressure into the trench, would sit here and mosquitoes, problems. So instead, it just soaks away into the ground. You get some some roots growing in there, works well. It's a little bit of heresy, it's not standard. We started talking about that 15 years ago, and some of the comments weren't very pleasant, but anyway, we got there. You can see some coiled ag pipe on the left. That's actually the pit you saw Pat constructing. Open at the base, half bury that with gravel. This was a different pit, very shallow. It's only about 400, same sort of thing. The coil was smaller. We just thought, let's bury the lot. Now it's business as usual, and that just runs some water straight off into a small park nearby. So that's keeping sediment out of there. Something we didn't figure on though is this one is in a street full of white cedar trees, berries, leaves, twigs, flowers. It fills up to the top with organic litter, and then it breaks down and disappears. And we thought, how long will it be till it clogs or overflows? And it never did. And year after year it would build up and then decompose. Because it's open to natural soil, we're getting invertebrates coming up and we're getting in situ composting. So we didn't clean that pit purposely for 9 years, and then we ran a water truck out there, checked the infiltration rate, still running effectively, 70 litres a minute I think. It's not QMEX, it won't take your 1 in 100, but in terms of the trees on the verge, it's massive. And after 9 years we pulled out the length of pipe, cleaned out the pit. Didn't need to, it was still working effectively. We were just nosy and wanted to see what was happening. No problem, working very effectively. And that was built in 2008, end of the millennium drought. Massive infiltration every year since. There's the infrastructure a year or so ago, perfectly intact, no heave, no subsidence, no cracking. There's hairline cracks elsewhere in the street, but that is pretty right. There's a stormwater outlet from this house here. It's lifted just a little bit. I think there's a root growing under it, but that's business as usual. This pit's fine. This is 11 years, this photo after it was, 11 years after it was built. And the shade density there, this tree's tapped into it. We built it here where we lost a tree. Compare that to that. The bio is working quite well there. Absolutely brilliant. But another concern early on was you can't have trees in biofilters. The roots get too big, they block up the pipes, just cause problems. Does anyone here know Brad Dalrymple? He works out of Brisbane, environmental engineer, top bloke. If you see him, tell him I want to have a chat. He did this project, he gave a presentation 11 years ago, and Mel, we should get this on the website. Melaleuca and Pittosporum, famous for root growth. After 11 years, 0.7 metres deep under this sort of bioretention basin, the ag drains are still clean as a whistle. These roots aren't 11 years old, these are a matter of months old, and this is what we found with root growth in permeable paving. It persists when conditions are good, and once the system dries out, the roots die, wither, and as they decompose, they increase the porosity of the system. So roots, fine root turnover they call it, increases the efficiency of drainage in low permeability soils. Trees are one of the best tools we've got. Some studies in the US show factors of 27 in one lab study and factors of 100 in others, increasing infiltration rate by 100 times. So trees are good in these systems. There's another one, bioretention system, drainage pipe under the central swale. That's only 10 years and half a metre deep, functioning like the day it was put in. Perfect. So let's scale that up a bit. We've got 1,500 square metre reserve. We can't put a massive biodiverse swale in because it's heritage listed kernel-like gardens. They're the trees that are staying. Peter Flood, you'd know, he designed this system. 70 metres of soakage system, big pipes, 52 centimetres, a 52 centimetre rockler, 70 metre length. I think the system is just shy of 40 kilolitres capacity. Picks up a lot of flow from around the catchment, goes for several hundred metres. Double side entry pits, each side into a junction box, risers vented at each end. Works well. My job, after Peter designed it and managed the construction, was to put the filter in the pit, and I got distracted and several months later got back to it. So this system had months and months of lots of leaf litter, not much sediment. It's an established garden area, garden suburb. And after many months, I came along and bent some ag pipe. I was looking at making a manifold to fit it to. In the end, just shoved the open ends into the 300 concrete pipe. And it's really ugly. This is not a horticultural solution, Joe. This is bush engineering. Anyway, you can see we ran it like this for 4 years after this went in, after a 3-month period with no filtration. Some sediments like you see in rain gardens, lots of gaps. So when the water level comes up, there's stuff getting through there. And after 4 years running it like that, we thought, is it getting clogged up? Do we need to do any maintenance? And the Adelaide and Mount Lofty Ranges NRM board, thanks Sam, gave us some grant funding. We put a camera up through. This is 4 years after that worst case scenario. These are roots coming through from Kikuyu. The fill varies from about 300 to about 600 deep above it because of the fall of the land. The bottom of the trench is on level grade, so the water disperses evenly. Level grade, no gradient. Anyway, Kikuyu roots come and go, and these roots are from some of the trees. Similar to what we saw in permeable paving, only dangling. I've spared you the videos. If anyone really wants to see the camera video going through here, it stops, turns, rotates. It made me feel queasy. I didn't want to show it here. But anyway, as it got to some of these roots, the camera actually touched the roots and they broke and dropped off. Because this is vented, it's in gravel, just like gravel under permeable paving, and this is middle of April, these roots are dead and they're brittle and they're dropping off. They're not going to develop into the massive great chunks of wood you see above ground. So trees and infiltration systems are really good stuff. And you can see the junction box is pretty well clear. All of this is broken off roots from the top, and after 4 years, without a proper filter in place, there's a very fine line of sediment and a lot of dead roots that are decomposing. So maybe a centimetre out of 52 in 4 years. If it continues at that rate, well, it wouldn't, because it's much wider at the top than the bottom, the middle than the bottom. But even at that rate, you've got 200 years before you need to empty it. So litter isn't a problem, silting isn't a problem, and tree roots aren't a problem. So build lots more of these systems and get the water in the ground. Works really well. And when you're finished with the camera, put new pipes in and use a little bit of expanding foam. Use less than we did. So that works really well. Now, a couple of anything to do with research, you always get surprises. And that's what makes it so interesting. Curb level here is about 200 millimetres above the level here, which is where the most distant riser is, vented riser, let the air out when the water flows in. So when the system's full and we've got water flowing in, it's going to be bubbling up back there. I thought about that and thought, should we leave that one sealed? No, it's 40 metres, it's 30, 40 metres, and it's only a couple of hundred millimetres. It's not going to be too bad if it is a problem. And that's what you see very rarely. And this is fantastic. There's a couple of holes and just upwelling under that head pressure from the street. And what really amazed me was, look how clean that water is, crystal clear. And you go and watch it going in the pit and it's filthy. It's only filtered through that pipe, and some of it's filtered through the gravel, but a lot of it goes straight through the pipe. And that's welling up crystal clear. Burn the clarity of that water and that simple system into your minds. We can use that, we can harness that. Amazing, that stuff. We're going to capitalise on that down the track, I'm certain. So when it charges up the riser at the end of the runs, we can see there's only a handful of occasions where it overflowed. We put a pressure sensor in there so we could measure the depth. So on those handful of occasions that it overflowed, you saw it spreading out from the riser. Is that going to cause anyone any grief? Well, no, because it's pouring with rain anyway, and it spreads out from the riser. I followed it out to the curb, and over several metres of curb, there's a 1 millimetre, if that, film of water just flowing over. You wouldn't notice it was there. So, low infiltration rate, plant trees, works well. Scale that down. Instead of trenches 40 kilolitres, make it a Treenet inlet and a Soakage well of maybe 50 litres. Sedimentation is a problem. The earlier ones had a much narrower, smaller radius dish, and they used to block up with a bit of sediment, and it was too steep for the road sweeper. The newer ones, 750 diameter, 750 radius curve, the road sweeper just cleans them out. I've seen these in situations where you can't get a road sweeper, loads of commercial activity, you never get to it, there's always a car there, whatever. Sediment filled to the top of the slot. It's generally pretty granular. Yeah, it does slow it down, but it never stops it. They weep, and the sediment actually becomes the final filter. When we were constructing some of these a couple of years ago, we had the face plates in the curb, the contractors were putting the wells behind, just connecting the pipes, and it started to pour with rain. So they were digging out site clay, really sticky clay, pushing it into the inlets and stomping it in, and couldn't get a seal, it was still dripping through. So if you think these things block up, and people will tell you they block up, tell them to go out next time it rains. If they've got a leaky shed or a leaky roof or something, just grab a handful of this stuff and see if you can seal your leak with it. Guarantee there wouldn't be a market for duct tape and silicone if that could seal your leak. Anyway, in that condition, clogged in the field, depending on the rainfall, 1.5 to 5 kilolitres a year, one of those inlets can harvest. And if you're putting 1.5 to 5 kilolitres directly behind the curb in reactive soil, there's a concern it might cause some shrink swell. There's similar concern with permeable paving, but no one had ever done any research. So we did some work on that. Harsha's here today. Her PhD was based on inlets installed in Eynesbury Avenue. There was about 28 of them along the road. This survey, see an inlet there, another one here. We surveyed the points at the inlet, 2 metres into the road, offsets east and west on the curb, and then between the inlets we surveyed the curb and the road midpoint, just to see if there's any difference. How much impact were Treenet inlets that can harvest between 1.5 and 5 kilolitres, maybe more per year, how much impact is that having on shrink swell? And there's some data that's never been seen before, it's not published yet. Back in October, take 0 as the datum. What you see there is heave in summer, swell in winter, heave in summer, swell in winter. And the first 2 points are the inlet at the top of the curb and the midpoint at the top of the curb. There's no difference at any point between the rise and fall next to the inlet or the rise and fall as far as you can be away from the inlets. No difference. The offsets east and west, again, no statistically different value there. So that whole unit and midway, it heaves in winter and settles in summer, and the inlets made no difference. It's really interesting, you can see the heave's consistent here, the swell's consistent there, more so there. But in early summer, the curb levels have started to subside, but under the road hasn't. 2 metres out in the road, sealed surface, there's just a lag. It's still doing the same thing, it just lags a couple of months behind. So increased here into late summer, early autumn, same here. But this one's actually interesting. This is descending before winter. starts to swell as soon as we get the rain, but under the road, still settling just marginally. So just that lag again. So Treenet inlets, good for trees, no issues with roots, no issues with ground movement, no issues with sedimentation. What's it got to do with the platypus? Joe, at the beginning of his presentation down at the biofilter, said, where are we taking this? How are we getting this together? How are we extending it? You might have heard Chris Daniels, Green Adelaide presiding member, say, what a challenge to get platypus back in the torrens. What a vision that is. There are so many challenges there, you could say it's virtually impossible. But it's not. Just list the challenges and start picking them off. And WSUD is one way to pick off most of those challenges: water quality, quantity, supply. We can do that. Maybe that's a bit ambitious. What about this guy? All they need is clean water for a sufficient duration to breed in and freedom from predators and disease. WSUD can provide pure water for the duration. The biofilters we've seen today, they fill up, they dry. Maybe we can combine Treenet inlets to improve the quality before it gets to the biofilter. Maybe we can have infiltration systems to hold some water. Several layers of biofiltration. Maybe we need an underground storage downstream from there that harvests and holds filtered water. Just run a polypipe from that with a float valve to a small lined pond on the creek bank. So as the creek booms and busts with urbanisation, we can have a pure, small pond that's permanent or very close to. So have you tried to catch tatties down the creek with kids lately? You're pretty hard pressed. We can fix that. Just we need to get this WSUD stuff together, big picture. We can do it for ourselves too. How long since you've seen people swim in the torrents? As a kid, I used to spend a lot of time in the torrents, wading through, and I can remember standing on Darley Road Forward, watching yabbies 2 metres deep on the bottom of the pools, getting in and trying to catch them. I'm not that old. You can't do that now. Well, I am getting that old, but anyway. Do it for ourselves. Thank you very much. And thank you to everyone who's had a hand in any of that.